हेलो स्टूडेंट्स, आज के इस लेक्चर में हम लोग जिस चैप्टर को डील करने वाले हैं वो है डिफरेंशियल इक्वेशंस, जो कि इंटीग्रल कैलकुलस का लास्ट चैप्टर है. When we study area under the curve, after that we come across this chapter, differential equations. So you should have a good understanding of integration and differentiation in order to do this chapter, because this is the last chapter of the calculus. So basically सबसे पहले हम इस बात को डिफाइन करते हैं कि डिफरेंशियल इक्वेशंस होते क्या हैं. तो as the words differential suggests that there is some derivative involved, there is some independent variable, there is some dependent variable. Like independent variable is x, dependent variable is y, and there is some derivative involved in that, and when we equate it to 0, then it becomes an equation. So like we can have an example with us. Sine of d2y by dx square plus dy by dx minus 3 is equal to 0. Or we can write minus 3x also. So generally in a differential equation, you will come across x, y, derivative of y with respect to x, double derivative of y with respect to x, and so on. So there should be some derivative involved so that you can call it a differential equation. Otherwise, if there is no derivative involved, only x and y are there, then it is simply an equation in two variables. It is not a differential equation. Now there are various types of differential equation. There is a type of differential equation which is called partial differential equation, and another one is called ordinary differential equation. So in our syllabus right now for JE, we have to study ordinary differential equation. What happens in partial, that you may have more than one independent variable. Okay, suppose UV, both these variables are independent, and there is a dependent variable, suppose y. So you can differentiate with respect to u also, or you can differentiate with respect to v also. In that situation, we denote it like this: derivative of y with respect to u, or if we are differentiating y with respect to v. So generally we don't take more than one independent variable when we study differential equation, ordinary differential equation. Here there would be a y, which is an independent variable, which is an dependent variable, and x is the only one variable which is the independent variable. So there would be dy by dx. We don't have to do any partial differentiation. Here we were doing partial differentiation. We were differentiating with respect to u and not taking v into consideration, or we are taking this derivative doing with respect to v and not taking u into consideration. So we have to study ordinary differential equation. That means we have one independent variable and one dependent variable, and there will be a derivative of dependent variable with respect to independent variable. So after knowing this, we have to understand that let me take the screenshot, or it's okay, I think video is already recording. So what happens ki here we come to a definition which is called order of a differential equation. So what is order of a differential equation basically? So order is the highest derivative done. We may have differentiated y with respect to x only once, or we may have differentiated it two times, double derivative, or 3 times. So whatever is the highest order of the derivative in that equation, that is called order of the differential equation. That is dy by dx whole cube plus d2y by dx square minus sine y is equal to x. So this is a differential equation because x, y and the derivative are involved. Now if I want to tell you what is the order of the differential equation, so you can see that there are two types of derivative. One is dy upon dx, whose power is 3, and one is d2y by dx square, whose power is 1. So basically the derivative is two order derivative. This is a second order derivative. And in that situation, you will say that order of the differential equation is equal to 2. So the differential equation has been having its order as 2. There is another term which is called degree of a differential equation. So degree of a differential equation is basically the highest power of the highest order derivative. But we have to find degree of a differential equation if the equation is polynomial in the derivatives. Not about y and x. The equation should be polynomial for derivatives. Then only degree is defined. Like in this example, can you tell me what is the degree of this differential equation? So actually, degree of a differential equation is the highest power of the highest order derivative. So here the power of dy by dx is 3, and here the power of d2y by dx square is 1. Out of these two, this is the higher order derivative. So its power is 1. So we will say that its degree is 1. We won't say that the degree is 3. Though there is 3 degree of dy by dx, but this is not the highest order derivative. Highest order derivative is this one. So we will take its maximum power. And there it is only in one place here. So we will take this as 1. This is the degree. In some situation, you cannot define degree. Like I'm giving you sine of dy by dx minus log y plus 3 is equal to 0. Or we can say plus 3 d2y by dx square is equal to 0. So if you observe here, this is not a polynomial in derivatives, because this is a term of a polynomial second order derivative. This is log y, so this is not a derivative. Dy by dx is a derivative which is an input for the sine function. So that means this term is not a term of a polynomial. Polynomial means there is whole power to the derivative. Here there is a whole power to the derivative multiplied with a constant. But here it is the input of a function which is sine function. So it is not a polynomial. So if you see that polynomial for derivatives is not there because of this one. In that situation, for this differential equation, you will say that degree of this differential equation is not defined. It is not defined. So it is second order derivative. Order is 2 because the highest times of derivative done here is 2 times. Here it is done 1 time. So order is 2. That is fine. But its degree is actually not defined, because though its power is 1, but there is a derivative over here which is not a polynomial term. So order is quite straightforward if I sum up this order and degree content. So order is the highest number of times the differentiation has been done in a differential equation. Degree is obtained if the differential equation is having the derivatives in terms of polynomials, and if it is in terms of polynomials, then the degree would be the highest power of the highest order derivative. So this is what we need to know. There are many examples which you can see in books. Like I will give you some here also, and I will see whether you would be able to find out the order and degree of those differential equations. It's quite interesting here. So there are a few examples. Let me write it here. Example number 1. There is a differential equation d cube x by d cube y by dx cube plus 3x dy by dx is equal to e to the power y. Another one is, you can simultaneously try to find the order and degree of each of them. minus d2y by dx square to the power 4 plus dy by dx is equal to 3. Third one is d4y by dx to the power 4 plus d2y by dx square to the power 2 minus 3 dy by dx plus y is equal to 9. Fourth one, let us take and we have fourth one d2y by dx square plus dy by dx whole square to the power 4 is equal to k square d cube by dx cube to the power 2. And let us take one more example, last example I'm taking. This one is fifth one. This says that d2y by dx square plus cos of d2y by dx square is equal to 5x. So these 5 examples I am giving you, and since you now know what is the order and what is degree of a differential equation, how is it being defined, so let us see what is the order and degree. If you take the first one, so order here is equal to the highest time derivative has been done 3 times. Order is 3. Now the highest power of the highest order derivative, so there is only one term of 3 order, so its power is 1, so degree is equal to. When we come across second one, so the order you can all easily see is equal to 2, that is 2 times it has been done, second order derivative, and its power is 4, so degree is equal to 4. In third one, this is 4 order derivative, this is second order derivative, 3 is this 1 order derivative. So again order here also is equal to 4, highest order, and the degree is the highest power of the highest order. So this is the only term of 4 order, so its degree is 1. If we talk about fourth one, so here you are seeing lot of derivative. This is second order derivative, this is 1 order derivative, this is 3 order derivative. So the highest is 3 order derivative, so order is equal to 3. And what is the degree? So the highest order is this one only, and its power is 2. So you'll say that its degree is equal to 2. Right? So this is a 2 degree term. And if we come across this one, so this is little different. Here order you can see it is 2 because d2y by dx square is the only derivative which is present here also and here also. So order is 2. But if you see the degree, so degree is actually not defined here because this second term is cos of d2y by dx square. So this is not a polynomial. This is not a term of a polynomial. So if you are taking cos, then inside you can take a constant, you can take x, you can take y, but you can't take dy by dx or d2y by dx square. You can't take derivative. So if derivatives are not in the form of a polynomial, you can't find the degree. Degree is not defined. Now let us come to the concept of formation of differential equation. And in this process, I will also tell you that what is it geometrically mean to us? What is it actually? So suppose we have a equation dy by dx is equal to x upon y with the minus sign. So this is a differential equation. Originally the differential equation may have been y dy by dx plus x is equal to 0. So this is the differential equation which I am rewriting like this. Okay. So I am taking y in the denominator, putting this on the right hand side. So in order to solve a differential equation, you have to get rid of this differentiation part. So our purpose is solve differential equation. But before studying about the solution of differential equation, we have to study formation of differential equation. So I will come to this. First we come to formation of differential equation. So suppose we have a circle, yeah, or we say a family of circle whose center is origin. So a family of circle whose center is origin can be written as x square plus y square is equal to r square, where r is the radius and it can be any value, because for the family you have many circles and they all have different radius. But yes, there is center is fixed. It is at the origin. So you are taking x square plus y square is equal to r square. So this r over here is called an arbitrary constant, because this gets varied as we take different member of the family. If you want to see what are those members of the family, you know that circle like this would be this one, this one, this one. So there are infinite circles you can draw. All will have different radius. So that is why this r is called arbitrary constant. So if you want to form differential equation, you have to get rid of the arbitrary constants. There is only one arbitrary constant here. So we have to get rid of this arbitrary constant. How do? We will differentiate. So when we will differentiate, this will become 2x dx. This will become 2y dy. This will become 0, because after all radius is a constant value. So with respect to derivative, it will be 0. So you will get x dx plus y dy equal to 0, and further you can write dy upon dx is equal to minus x upon y. So actually the curve was given like this, family of curve, and you have expressed that family of curve with the help of a differential equation. And in order to do that, now you have got rid of the arbitrary constant, which is r. So there is no more r here. But instead of that, we have a differential equation here. If any equation is having two essential arbitrary constants, then you have to get a differential equation which is of second order. So as there are number of arbitrary constants which are essential, those are the order of the differential equation. So it is first order differential equation. If in case there was two arbitrary constants, so we will get a second order differential equation which will represent the same curve. Now let us see, can this differential equation really represents this family of curve or not? Because this also represents family of curve and this also represents the same family of curve. So what it is actually, just geometrically, let us understand what is dy by dx. Dy by dx means slope of a tangent at a point x comma y on the circle. So if we take a point on the circle, any one circle, let us take this point and make a tangent, then this tangent would have a slope which is dy by dx. So this point is suppose x comma y on the circle. So it says the slope, this slope of the tangent is actually minus x comma y according to the differential equation of the curve. And this will be followed by all the points on any circle. Is it true? Let us check. So let us consider that this is a circle and it is having a point here. Suppose 1, 2. There is a point 1, 2. And I'm taking the circle here as x square plus y square is equal to 5. So if x square plus y square is equal to 5 is this circle, then the point 1, 2 obviously lie on it, because 1 square is 1 and 2 square is 4. So 1 plus 4 is equal to 5. So this is the point which lies on the circle. Now if we want to find the tangent here, so you already know in coordinate geometry that at a given point, how do we find the tangent? We write x square as x into x1. So this is x into x1, which is 1, plus y into y1, which is 2, is equal to 5. So this will become x plus 2y is equal to 5, is the equation of the tangent. And if you see the slope of this tangent, this slope would be minus of coefficient of x, which is 1, divided by coefficient of y, which is minus a by b. And if you see that the slope according to this differential equation, so this will be minus x. X is 1 and y is 2. So yes, same slope is coming. So overall, we can try to understand that this family of curve represented by this equation can also be represented by this differential equation, same family of curve. Here only we have an arbitrary constant. Here it is in the form of derivatives, and we have removed the arbitrary constant. So this is the formation of differential equation. Now let us come to the solution of differential equation, which is relatively a big topic, and there are different methods by which we solve differential equation. First of all, we have to solve this differential equation. So solution of differential equation is just the inverse process of what we did here. There was an equation given and we formed a differential equation. Now there is a differential equation given to us and we will form the equation. So of course there will be arbitrary constant in the final answer. So if it is a first order derivative, then there will be only one arbitrary constant. If you have second order derivative, then you should have two arbitrary constants. But the solution of differential equation syllabus does not cover the second order derivative. We have to only study linear differential equations, first order derivative. So solve differential equation for this. So this will become, what we will do, we will multiply y with dy and we'll write x with dx and integrate both the sides. This will be y square upon 2 is equal to minus x square upon 2 plus constant of integration. This constant is that arbitrary constant. So this will become x square plus y square is equal to 2c. Sorry, a call has come. So x square plus y square is equal to 2c. And this is actually r square, or you can write 2c here. It's r square, which is an arbitrary constant. So this is solution of differential equation by the method of variable separable. So what happens in variable separable form, that the y will separated with dy and x will separated with dx, and both the sides we will integrate. But it is not always the case that you will get a variable separable form. So we need to know many more methods also. Like one more type of question which actually come, dy by dx is equal to function of x plus ax plus by plus c. This is a representation. Actual question में a b c की कुछ value होगी और जो function दिया हुआ होगा, that function is some sine function or log function or simple algebraic function. Could be हो सकता है. So in this situation, if you want to apply variable separable form, so this is second way of solving differential equation. First way is very straightforward, that you have to solve the differential equation by variable separable method. If the variable can get separated, x and its functions can go on one side with dx and y and its functions can go on another side with dy, then the variable separable method will be applicable. Integrate both the sides. In this situation, what we have to do, we have to do some substitution. So we let ax plus by plus c is another variable t. So the function of this whole thing I am taking as t. Now if we differentiate, this will become a plus b dy by dx is equal to dt by dx. This is how we can write it. Now what we will do, dy by dx, which is here on the left hand side, from here we can write it as dt by dx minus a upon b. So this is dy by dx. On the right hand side, function of b. So you write it like this. Now after doing this, variable separable is relatively easy. Take this b on the right hand side and multiply. Take this a on the right hand side and add. And finally, dt upon bft plus a is equal to dx. Now it has become variable separable. Here you can integrate it because there is a function of t and some constants with respect to dt. And here there is only x. So you can separately integrate them. So here we have to first use the concept of substitution, and then we will finally integrate. And when the final answer will come, we will again replace t, this t, with ax plus by plus c and get the actual result. So this is second type of solution of differential equation method. Then we come to third type of solution of differential equation method, that is homogeneous differential equation. Third form is homogeneous differential equation. So in homogeneous differential equation, what happens actually that it would be of the form dy upon dx is equal to function of x comma y in the numerator and some another function of x comma y in the denominator. Now what is important here, that if x comma y and gx comma y both are homogeneous functions. What do you mean by homogeneous functions? Homogeneous functions are those whose all the terms have same degree. For example, x square plus 5xy minus y square. This is a homogeneous function because first term is of 2 degree, and actually this term is also of 2 degree. X 1 degree, y 1 degree. So overall 2 degree. This is also of 2 degree. So this is a homogeneous function. So what we need to know, that function of x comma y, which is in the numerator, and function of gx comma y, which is in the denominator, both are homogeneous functions. That is, their all the terms have the same degree. Okay. Additionally, the degree of both the homogeneous function is same. Both are homogeneous functions of same degree. If you are taking f of x comma y as 2 degree, then g of x comma y must also be of 2 degree. If numerator is of 3 degree, denominator should also be of 3 degree. In such situation, this is called homogeneous differential equation. Let me give you an example, and then we will know how to solve a homogeneous differential equation. So if we have dy by dx is equal to 2x square plus 5xy minus 7y square, which is a 2 degree in the numerator. In the denominator, we also have a 2 degree every term. So let us make it xy minus xy and 2y square. So I have made a 2y square minus xy, a 2 degree term of gxy. Now, if we see that it is a homogeneous differential equation, that is the numerator and denominator both are of same degree and are homogeneous, then we have to do a substitution here. We will write let y is equal to vx. V is again a variable, so I am relating y with respect to x with v, or we can see that v is actually y upon x. V is actually y upon x. So y is equal to vx. Now in this situation, when you will use this substitution, I'm giving you some time, around 2 minutes time. Try to find dy by dx and form the new equation in which there will be actually only x and v. Y will not be there. Just try for 2 minutes. Okay, so I hope you have tried. So here, when we differentiate y with respect to it, you'll get v plus x dv by dx. This is what you will get. And when you substitute this and this in the original homogeneous differential equation, dy by dx will be written as v plus x dv by dx, which is equal to 2x square plus 5xy. And what is y? Y is equal to vx. So 5vx square, this will become minus 7. And what is y square? V square x square divided by 2y square. So this will be 2v square x square minus xy. So this will become vx square. So what we have done, we have substituted y everywhere. Now this is in terms of only x and v. And what happens, which is very important to understand here, that since the numerator and denominator were homogeneous functions and their degree was same in the numerator also, denominator also. So after doing this substitution here, you can see that same x square can be taken outside from the numerator and same x square can be taken outside from the denominator as common, and they will get cancelled. So what we will get here actually is a function of v alone. This will be 2 plus 5v minus 7v square upon 2v square minus v. So you can see that the right hand side is a function of v. There is no other x variable. And in the next step, write x dv by dx and take this v on the right hand side. So this will be minus v. And when you will calculate after taking LCM, you will get that this is equal to 2v square minus v in the denominator, and minus 2v cube is a term which you will get here, minus 2v cube, then plus v square, and this minus 7v square will be minus 6v square, and plus v, 5v plus 2, 5v plus 2. So this is how we are getting it. I'm not further solving it, I'm just trying to give you the method. The rest process is the integration, which you have already studied in integration. So what we get finally is that we have a variable separable differential equation. Take this dv here and all the terms of v from there, 2v square minus v upon minus 2v cube minus 6v square plus 5v plus 2. And take this dx on the right hand side and x there in the denominator. So now what we have done variable separable form, which was the first form. So the purpose was basically this, that when you want to use homogeneous differential equation by this substitution, which is y is equal to vx, you will get finally a variable separable form. You integrate this, which will be log of x, and integrate this. This is the indefinite integration, which we have studied in indefinite integration, and finally get the answer. And don't forget to replace v by y by x, because we had taken v is equal to y by x. So this was homogeneous differential equation. Now we have done till here. We have few things left right now. One is reducible to homogeneous differential equation. Some differential equation is not as such homogeneous, but if you do some manipulation or substitution, those can be changed into homogeneous differential equation. Second thing is linear differential equation, which is very important. We have to study that. It has two forms, form 1 and form 2. And then we will study reducible to linear differential equation, which has another name, Bernoulli's equation. So, and then we will come across fourth point, which is orthogonal trajectory. So, and then we will practice some problems also. So in this first lecture of differential equation, I tried to tell you about the type of differential equation, that is ordinary differential equation and partial differential equation. I also told you about the degree of a differential equation and order of a differential equation. I also told you that how to form a differential equation. And next we started solution of differential equation. In solution of differential equation, I told you that variable separable form. Then second one is a specific type of differential equation where you have to do a substitution. And then third is the homogeneous differential equation. In the next lecture, we will complete this chapter, and there we will study these 4 more topics and may also discuss some questions. So thank you students for this class.